All right, Matt, you're up.
So I can everybody I guess so. So hey guys, my name is Matt. I'm the director of academics for the Carleton Computer Science Society, and I just want to do a couple quick announcements just before this presentation got started. So for those of you who don't know, the election period for the CCSS will actually be starting tomorrow and running until March 27th. So for those of you who don't know, the executive positions within the CCSS are elected positions. And tomorrow you guys will be receiving a ballot link via your Carleton emails that will let you vote for the next CCSS executive board. So when you get that, please take the time to read over the platforms of each of the candidates and make a well-informed decision on who you hope will be the next executive team. So yeah, without further ado, please take it away, Ryan.
Hey. So hi, everyone. My name's Ryan, and I'm going to be giving you guys a little talk on what it takes to become a senior engineer in about 2 years of being in the industry. I want to say a couple things about this whole little tool we're all using. It's my first time using it too, so we'll see how it works. If you have problems, say so in chat. We'll figure it out. I am recording this whole thing, so the videos will be available, and I'll even edit out people who don't want to be seen in it. So that'll be a part of it. I would like for anyone who has a question, at any point you can use the little questions tab that's over by chat and put them in there. You guys can vote on which questions you want to answer. I'm going to try to leave a whole lot of time for Q&A because when I was in school, talking to people who have been out in the field for a while was like the best part about it. So I want to leave as much time for that, but use the questions. That way I make sure to get to it. And I'll try to keep an eye on the chat, but I'm not like a Twitch streamer, so my brain doesn't work that smart, so we'll see how it goes. But let's get started. So a little bit about me. I've been in the industry since 2009, I guess. Went to school for computer science, went to NC State, and then studied abroad in Japan. That's where this picture's from. It's me eating a squid. It's not a piece of pizza. And at some point in my career, I kind of decided that writing code was like the least responsible thing I could ever do. And we'll talk a little bit more about that later. And so I started to try to help companies and teams do better and feel better and get better results instead. So I've been a consultant now for a number of years. So I work for startups all the way up to the Fortune 100. And my night job is helping developers figure out how to make the most of their career. Because if you haven't tried to get a job yet in software, it's pretty horrible for no good reason. And I hate that about our industry. And so I try to make sure developers get the jobs they want, negotiate super good pay and all that stuff. That's what I do on the side. So that's me. So why are we going to talk about being a senior engineer if everyone here is still in school? The main thing I want to say about that is for a lot of developers that I work with, becoming a senior engineer is one of the first major promotions that feels like a significant distinction. Becoming a senior is sort of an acknowledgement that you have a pretty good breadth and depth of technical skill. Your opinions are valued and sought out and respected, and other more junior engineers will come to you for advice and help. The promotions you may get before that may not quite feel that way. It's sort of like you're earning your keep sometimes, but a lot of people I work with, becoming a senior is a pretty big deal to them. I should also say at this point, there aren't really standard titles in our field. So while senior seems to be a pretty common one, what happens before that and what happens after that varies very wildly. So senior seems to be the first major promotion that's kind of common that people really get excited about. And the nice thing is you can start preparing now for that. So when you leave this talk, I will teach you 2 techniques you can start practicing while you're in school that will help you become a senior faster than everyone else and be hopefully a better senior than most of your peers. So that's the end result. That's what we're on the hook for. That's what you can say I did or didn't deliver on. So what's it might be like to be a senior engineer? Well, the way I might describe this is in terms of where you spend your energy. So before you're a senior engineer, most of your energy is going to be spent trying to figure out the learning new patterns. Oh no, I'm frozen. Am I frozen? Uh-oh.
It froze for me for a brief moment.
Okay. Here. We'll lower the definition and see if that helps. Okay. So before you're a senior, you're spending all of your energy focusing on solving technical problems, learning the tech, learning the frameworks, learning the code, learning all the tech stuff to do your job. You're developing a huge amount of patterns that you will begin to reuse as you solve problems. All that is what's happening before you're a senior, and as you become a senior, you have a whole lot of patterns built up in your head about how you solve things, how you learn technologies, how you deal with certain issues, and so a lot of your energy isn't spent on the tech anymore. You can solve problems pretty rapidly because you've already solved one, so you think about, that's kind of like this, and you reapply it again. So where does that energy go? It goes to a lot of problems around the technology. So you begin to see things like, my teammates seem to struggle with these types of things, or we have these huge quality problems in our whole code base, or the overall design of our system is absolute turd, so we need to fix it, or we keep getting these crappy products that aren't moving the needle and we're wasting our time. You begin to see these things more clearly, and you have energy to begin to figure out how to address them. So with the foundation of that set of technical patterns, you begin to apply yourself to other areas. And in a way, you begin to think about how you can improve general conditions around individual technical pieces of code. That's what it's like to be a senior. So what you wind up doing a lot of your time is thinking deep thoughts about what are the repercussions if we take one technical path versus another. Who should you sit with for the day to help them learn better? Going into meetings with managers or product people to talk about what technical options exist for some upcoming product or project. These are the activities that it feels like, but it's all built on the foundation of pretty good technical experience, so you can solve those problems rather rapidly and move on to the other things. So that's kind of roughly what a senior is like. It varies quite a bit, but you can also think of the further up you climb in the ladder, you spend less time on hands-on a keyboard coding, and you spend more problems ahead of the keyboard. So you're thinking about architecture, design, you're thinking about teams, you're thinking about timelines, deadlines, things like that. So senior is one of those first steps up where you begin to help other people in the situation around you. So here's the problem. You're learning all these patterns. You're learning all this cool stuff. You're becoming a senior. Just because you're a senior, does that mean you're actually any good at what you do? And the answer is no. Just because you're a senior, that doesn't mean you're actually good at what you do. It just means you have a whole lot of experience to make the same mistakes the same way. That's the hard part about this. And thankfully, there's a way to redeem ourselves, but this is one of the hard things about what we do is it's really hard to know good from bad. We know a lot of bad, but it's really hard to know good. And as we do our work, we're developing all these habits and we're developing all these patterns, but that doesn't mean they're good ones. They're just what we repeat. And so as you go out in the industry, you'll see tons of code bases that are all kind of the same and all kind of icky for the same reasons. And you'll see very few examples of something exceptionally better. And this is one of my bigger problems with our industry, that I kind of call this the plateau of software, that kind of no matter what level of experience you have, the bar of ability seems to be somewhat frozen. That everyone keeps talking about what good code or good design or good architecture should be, and yet there are very few examples anyone can point to of what it actually looks like. So we're all still trying to figure out what that is while committing the same crimes in our jobs of creating bad code. Now, I think our industry does have to get better because the demands on us are getting higher at the same time, right? We're getting asked to build more complex systems that have to run faster and be more usable, but our technical ability plateaued. And I have a problem with this. And so what I want to teach you is stuff that will help you break the plateau, and I'll even tell you how you know you're actually better. So we're going to move to, well, a funny idea. When you're coding assignments at school, how do you check that they work before you turn them in? I'm not going to ask you to answer the question because you don't have to oust yourselves and say, I don't have time for that. I'm lucky to get it done. But more than likely, there you go, right, Jake? So more than likely, the most people have time to do is run it a few times and see that it kind of does what we hope it did. That's about it. And then we turn it in. That's how we make sure our assignments work. And then people will, grade us on that. So here's the thing. I'm going to call that a spot check for the sake of this conversation. That spot check is fundamentally the same thing that as a student you do, is the same thing that professionals with any number of years of experience do to this day. That means that the software that runs your banks, that runs your finances, is built by developers who test their assignments the same way you test your homework. They don't do anything magically different. That's how they test it. Or the people who do flights and routing and all that stuff, they test it the same way. So it's a little bit terrifying to think this is what our industry is like. They spot check the same way they did in school for assignments. By the measure of how you test your software in school, you are already a senior engineer. That's the bar that we're at. And hopefully that's terrifying. So what we want to talk about is the first technique that you can learn in school that will actually make you significantly better while you're in school. Maybe even get your grades up a little bit if you want them to, but definitely it will get you past the plateau as well as make you a senior engineer better and faster. And it's called TDD, or test-driven development. I don't want people to get hung up on the test side of it. That's kind of a byproduct, but you have to know how this works. And I don't know what you have learned in school. If your curriculum was anything like mine, you don't actually learn how to test software. You go out into the world and into the industry, no idea how to prove your software works as a professional. We'll see. Maybe I'm wrong, but that means I'm going to tell you a little bit about what a test is. So let's think about a little idea here that testing is nothing more than getting an expected output, considering you put in specified input, right? That's it. You can predict what's going to come out of your program given you put specific things in. That's a test. The skill around testing is recognizing what kind of inputs can create what kind of outputs, and developing this kind of way of seeing your system where you can create really interesting permutations of things that put your system into weird conditions and yet you can control it. That's testing. So let's take a really simple case. Let's say you created a function that just adds two numbers together. That's it. So a spot check might say, all right, I put 2 and 2 in, I get 4. Cool. I put 2 and 3 in, I get 5. Right on. That's what most developers would consider sufficient. What most developers probably will not consider is adding zeros or a negative 0. What happens if you get a negative 0 plus a 0? Should you get 0 or negative 0? I don't know. What if you add 0.01 plus 0? What should you get? Right? Decimals, doubles, floats, all those kinds of things in software are very dependent on what language you choose as to how they behave. You could wind up with a 0. You could wind up with 0.1. You can wind up with all kinds of stuff depending on how your technology handles decimal places. But you're just trying to add two numbers. What if you add the letter A and the letter A? Does it give you an error? Or does it convert that A to its integer representation, which typically is 26, and you get the answer 52 back or 62 back? Who knows? As you learn to test, you begin to see all these different inputs create different outputs. And if you think these are reasonable cases, I guarantee that software is complex enough that all kinds of crazy stuff will happen to you. But this is testing. Now let's talk about automated testing. Instead of running those spreadsheet stuff by hand, plugging the numbers in, and what happens, you write a program that does it for you. That's automated testing. That's it. And that's all I really need to say about this topic of testing before I explain TDD. Hopefully that wasn't too much new material about testing, but I had to assume that you guys were taught what I was taught, which is nothing about testing. So the first step of TDD, it's just really 3 steps for the sake of this conversation. Step 1, you have to write a test and see it fail. So this is a little code snippet from example code base that I wrote. And the thing about this first step of writing a test is quite literally you have to write the test code before you write any other code. So if you're going to write a function that adds two numbers, you write the test before you ever wrote the function. That messes with people's heads. This is also the step people get messed up on the most. Writing a test first and watch it fail. If you don't see it fail, then you don't know if when it passes it meant anything. You have to see it change from pass to fail so you know something's changing. So you write the test. Now, by the way, if you go out and research TDD or look it up, you'll find a lot of controversy about this technique. It's often talked about and very rarely done. And most of the people you're going to find on the internet talking about it have never done it. They've only thought about it, and in their heads, they've come to a conclusion, and they will tell you what that is. So finding someone who's actually done TDD is actually a lot harder to find. So just be aware that if you go and Google TDD, you'll find a lot of people saying, it's not practical. They've never done it. So the first step here, and the step everyone gets messed up on, write the test first. And this is a little snippet of Ruby code with RSpec. That's what that is, if you're not sure what the syntax is. What I would say in just a few seconds, though, I have this method declared here in the middle, find largest in set. That means I decided that exists in my test, but there's no code to support it. My first error will be that method doesn't exist. Or if I was doing this in something like Java, it won't compile. That's a failure. Good, I'll take it. When I put it in, it'll fail for another reason. Cool, I'll take it. And I begin to work on the next step, which is do whatever I can to get it passing, which means I can hard code stuff. I can return values that don't make sense. I can do whatever I need to make the test pass, because I'm going to do this in a cycle. So I'll come back and fix it. But in this case, that test wants to get the answer 5. I'll just return the answer 5. It's fine. I can fix this. So I have a failing test. I have a passing test. And the last step, clean it up. If it looks ugly, if it's named bad, if I hard-coded something, if something's icky, take a second and clean it up. That's the step. All 3 steps right there. Then you start over and you write a new test that fails, and then you make it pass, and then you clean it up, and then you start over again. And you just keep doing this. Now at first, because TDD is a skill, it will take time. You have to develop sort of the muscles to do it and the patterns to do it. But when you get really quick at it and normal with it, this begins to take 30 seconds to 5 minutes per cycle. And why this technique is the one I tell you about the most, if you take nothing else away from my talk, TDD is something you should invest in now. The reason why it's so powerful is normally when we're developing code, right? We're developing in these big lumps. We're trying to complete the assignment. We're trying to add the feature, fix the bug, these big blobs of work. And by the time we're done, we have a hard time learning from the big blob. We don't either have time, or there's so much that's going on. We had to make so many decisions. It's really hard to go back, narrow down something really salient to learn from that we would do better. We certainly have impressions of what we would like to do better, but they're vague. And that also means that we're developing patterns on the first roughest draft of our code. The patterns we use to solve problems in the future are built off the rough first draft. That's why the bar stays low. Everyone is learning how to be good at software off of the rough first draft. When you do TDD, you force yourself to stop and look at a tiny bit of code and clean it up. So you're learning off the second draft. And you're constantly asking the question, how could I make this better? Whereas the rest of the time, we're lucky to have energy to do that by the time we're done with our big blob of code at the end. So this by nature forces us to learn and build patterns off of that second cut of code. And that's why it puts us past the plateau as we keep learning instead of kind of getting to a point where we've seen a lot of stuff, we're repeating the same patterns and we're reusing them. We can begin to develop new ones consistently with TDD and go far above what's normal. And I think I said I would tell you how you know that it's working. So at some point, you'll do what's called a code review. Code review is nothing more than when you finish a blob of code, you send it to your peers, and then they will judge you for what you have done. They will judge you for your crimes and tell you how you should make it better based on their opinion. Now, if you're above the plateau, then their reaction will be something of awe and silence. And how it typically goes is they'll look at your review and they'll say, code's really good, but I can't really explain why. And I'm not sure what I should do about it. And this is literally conversations I've had with people and my students have had with people. Because what's happening is intellectually, they are now seeing code for the first time that is an example of the stuff they talk about. So intellectually, they understand how good it is, but it is also so different than everything they've ever seen that it's triggering a response of caution because it's different. And it's totally weird and human, but it happens. And inevitably that'll spark a huge debate against everyone about why the code you submitted was so good and what we should do. All that stuff will happen. But the moment that they say your code is really good, but I can't put my finger on it, that's when you know you've gone above the plateau, because they can recognize for the first time what good code looks like, but they can no longer explain why. That's how you know it works. So that's the technique. And why I would recommend you learn it now in school is as you develop the skill for it, not only will your coding ability advance quickly, that's the promise of it, but also, do you think your professors and TAs do anything more than a spot check? Do you think they magically know all this stuff themselves? When they decide to take points off of your assignments, is it really thoroughly vetted in a defensible position? If you're the kind of student who wants every point possible and is willing to go fight for it, showing up with a code base with hundreds of test cases that prove it works is a better position to walk into than a please. So if you're that kind of student, this is like going to court with a bunch of evidence, right? And more than likely, the TAs and the professors are in the same boat you are, which is spot checking. So there's the other thing. You might actually get a couple extra points out of it. Next thing I want to talk about, this is the second technique, and this is a little harder to develop. This one's all internal. So essentially, one of the things that's going on here is that because as a senior, you begin to focus on a lot of problems around code, you're dealing with, so good point, William. So yes, there are often programs that are built in that test your software, but were the cases that test your software built by someone spot checking, or were they built by someone who comprehensively tested your software? Just because they have a piece of software that does it doesn't mean they did a better job of being in their cases. They could have put in bad cases. So that was what was true for me. They had software that checked everything, and we found ways of breaking it. So anyway, because you will work more and more around the problems of software, it becomes really, really important to understand what might be going on around you. So you have to understand other people's perspectives, their backgrounds, things like that. Otherwise, the opinion you offer will be ignored or rejected or dismissed, and they won't be as well-rounded as they could be. Now, there's a book called Thinking Fast and Thinking Slow by Daniel Kahneman, and he kind of identifies all the biases that most of us might have heard of him culturally, like confirmation bias, survivorship bias, and all that stuff. He's one of the researchers that identified a lot of them and wrote them all down. Anyway, there's a huge bucket of these that he kind of calls in the category called what you see is not all there is. Man, I misspelled there. I apologize. I am fired. So what you see is not all there is, which is a way of him saying that the way our brains like to work is it likes to take all the information in and keep everything that sort of goes along with stuff it's already seen and kind of ignore stuff that it hasn't seen. So when we form an opinion about what good looks like or what we should do, we're fundamentally basing it on what we know and what we see. We are not basing our opinion on what someone else knows and what they have seen, because we have no idea. And yet that's the challenge. We have to incorporate other perspectives in with our opinions if we're going to be heard and have the best possible chance of making things better. So what I try to teach people to do is to recognize a moment when they feel like they want to argue a point, debate an opinion, and before they open their mouth, like feel the words coming out of your mouth, stop and ask the question, what might they see that I don't? And usually awareness by asking the question is enough to calm down and not assume that their opinion is bad because it's not like yours, but it can't be. They didn't experience what you've experienced. They didn't see what you've seen. Their opinion in their mind is totally right based on what they've seen. And the reality is, as software developers, you will work with other non-software developers. You will work with product people. You will work with QA people. You will work with analysts. You will work with managers. And a lot of them aren't going to give a crap about the tech side of things. And so you have to hear their perspectives very openly, which means kind of being a bit more humble and empathetic about what I've seen is just a tiny piece of the puzzle. And the more I see of the whole puzzle, which is everyone else's stuff, the more recommendations will be heard and respected. So that's the second one. It's a little bit of a softer one, but why I chose to mention this now is everyone loves group work, right? Where one or two people do all the work and then everyone else seems to vanish and people are like, should we tell the teacher and make sure they get an F? Did nothing? I'm assuming that's still a universal truth. Well, at this point, I would feel compelled to ask, well, what's going on for them that I don't see? It could be that they are helping just in ways I didn't recognize. It could be they have some crazy crap happening in their life that if I knew about it, I wouldn't be so judgy all the time. So you might make group work a little bit more, less vicious, to use that word, with this technique. And it's as simple as remembering to ask yourself the question, what do they see that I don't? So those are the two techniques. If you're going to favor one over the other, TDD is my recommendation. It'll make you one of the strongest programmers everywhere you work by far. The second one will make you a leader faster. But that's really all I wanted to get into for this talk. It may not be what you thought. You may have thought I was going to recommend how to learn technologies or which tech to focus on. Problem with those things is it changes so much, and you can't predict what you're going to run into at a company or what companies use, so you will just learn. And TDD helps you with that just as well as anything else. So what I want to close with is a couple resources here. So I made a YouTube video a while ago showing what TDD just looks like with me explaining the steps, because it's much easier to see it than to hear it. So there's a little video there, and there are other really good videos out there. There's a guy named Gary Bernhardt who runs a site named Destroy All Software, and he does screencasts that show all kind of great software topics, and he does TDD while he does them. It's not his focus, he just does it, and he's masterful with it. So it shows you how compelling it can be. And then the book I mentioned, Thinking Slow. Those are some resources here. And the last thing, so because you all sat and listened to me, couple of things. This QR code will take you to a Google Drive where you can download a copy of my book for free, which tells you everything I wish developers knew about how to get a job in the industry. Everything from how to read postings, building resumes, all the way through negotiating higher salaries. So it's there, it's yours for free. Have fun with it. If you like it, please give me an Amazon review, because otherwise people never find it and buy it. And the other thing, feel free to connect with me on LinkedIn. I have a newsletter, which I'd love for you to join if you feel like it. But otherwise, if you enjoyed this talk or want to hear anything else, let Matthew know, and I will come talk and do whatever it is that you guys would find helpful. I really do want to make sure the next generation of developers are far better than mine. So with that, maybe we can do a little Q&A for the rest of our time, but as far as I'm concerned, you're done being lectured at by me. Thanks.
Thank you for the presentation.
So Forrest, I see you raised your hand.
What? Sorry, I didn't mean to interrupt there. I was gonna bring up the same thing about Forrest. Sorry about that.
Yeah. All right. Forrest, you're about to come on stage, man.
Hello. Can you hear me? Okay, perfect.
Yeah.
Yeah, so I think I'm like 6th year at Carleton. I've been around the block a lot of times, and so I think test-driven development is something that's definitely echoed a lot in the chambers of software engineering. And if you go to conferences, it's something that you hear a lot from many different developers in different locations. But I think something that was really not touched upon, and I'm kind of bummed that you didn't like do like a whole segment on. Oh, you did a segment on it, but I'd love to like hear an hour-long talk. Is like the idea of like the empathetic developer. And so I think this is a very interesting topic. But I'm also wondering what your thoughts are on. So there's a conference that a lot of Carleton students go to every year called QSEC, and it takes place in Montreal in January. And last year there was a talk on like soft skills by developers. And so, for example, like not necessarily caring as much about or like not looking as much about like your skills and like what you can code and like what your skills are algorithmically or whatever, but instead what do you bring to your team with your personality and like with how you communicate with people and so on and so forth. And so I was wondering if you could have like a sort of like a 1-minute overview on your thoughts on soft skills and like how they affect developers and software engineers in the industry.
Yeah, so I think this is you're bringing up a really good point, right? So too often our industry focuses on the tech side to its detriment. And the reality is the idea of the genius that works alone and does great things is pretty well dead. Software is too hard now. It takes people working together to solve really hard problems. So the more humanity we bring back to our industry, the better it gets. And that's unfortunately been sort of not a concern. Certainly as I've been a developer, it's becoming more of a concern now. But, you know, the best teams I've ever worked on, they knew each other's birthdays. They chose to go eat together. They played games after work. When they saw something that didn't look right, they could actually talk about it without someone feeling like they were being, burned at the stake for it. They could laugh together. Those are all human things, and they build a platform upon which better decisions get made instead of everyone trying to prove themselves. I think, my personal opinion is software developers generally thrive on cleverness. We like knowing we can solve problems, which means we kind of don't like feeling like we don't solve problems well. And that sort of core belief that a lot of developers has, I think, gets in the way of recognizing that, other people bring things to the table and it's totally fine. There's room for everybody. So there's another idea called like egoless code and all this other stuff where code is a byproduct of what we do together. It's not the end result. That's just a thing, and it's supposed to change, and it can be thrown away and set on fire, and it changes, and it's fine. But we would rather work together and do that than, kind of die by the merit of code. That's not a fun place to be at all. How to go about doing it, though, that's a tough one. There's a couple good books that I tend to recommend to people that are ready to like really focus on that stuff. One classic one is called How to Win Friends and Influence People, which sounds super manipulative, but the TLDR of it is ask people how they're doing and listen. The other one is called Humble Inquiry by Edgar Schein, and it basically tries to drill into you that if you can't be curious about another person, then they have no reason to care that you exist. And so be curious. Get to know people. It's totally fine. Most of my job as a consultant is talking to people. And I don't convince any software developer to do TDD or any of these other techniques or to improve on its intellectual merit. It only ever works because they trust me with what their future could look like with such a technique in their pocket. I only am effective because of my ability to build and maintain solid relationships. I only work with empathy and influence. There's no amount of scientific studies that convince anyone of this stuff. But if you trust me, you give it a shot. So it's core to how we work. And it's the next horizon, I think, for our industry.
Awesome. Thank you very much. And one more question, if there's nobody else here who's wondering about anything. But you focused a lot on what as a developer you can do to become senior and sort of push yourself ahead, and like taking these techniques forward, you'll be a more effective developer. But then what if you looked at it from a different perspective? So maybe, for example, what would you recommend to someone who wanted to become like maybe a team manager, or even if someone was like running a startup and they came to you and asked how could they work with their developers better? What types of things would you say in that case?
So all right. So I kind of hinted at it a little bit, but the more you move up the leadership chain, your skill set begins to change. And the reality is that when you come from a technical background, even to leadership, no one ever teaches you the shift from moving away from tech being the foundation you work on to people being the foundation you live with. You have to sort of jump to a different thing. So the previous conversation about empathy, if you don't learn it as a developer and you suddenly, through technical merit, earn yourself into a management position, it can be horrible for you and everyone else because your job is not code and tech, your job is people. And the further up you go, the more this becomes true. You do have to learn some other skills like project management and budgeting and stuff like that, but that's not insurmountable. But no one, how do I put it? I guarantee that everyone here will work for a company and a boss that they hate and find ways not to do what they ask them to do. At the end of the day, even if they have authority, they can't really make anyone do anything they don't want. It just becomes subversive. So effective leaders are effective with people. And so the fundamental premise of learning to work with other people and be curious about what's going on with them, and trust being one of the more major currencies you have available, that's what I would say you focus on.
Awesome, very much. Those were some great insights. I appreciate it.
So what other questions does anyone have? It can be anything. It doesn't have to be related to this talk at all. It can be whatever you feel like. It's fine.
Can I ask you a random question?
Of course.
Sorry, I won't. I'll ask after Robert goes. Robert just requested mic access, but I'll keep it.
Ooh. Cool. I didn't think anyone would do the request the mic. I thought everyone would just type questions in. So this is kind of exciting. What's up, Robert?
Hi. So so this is a bit of a random question, but so first of all, what university did you attend, and second of all, what was your favorite course within your program there?
I went to NC State University for 7 years. I was not the best student. My favorite classes were, so curriculum-wise, my favorite class, I would say it was a toss-up between, it was a junior level class called software engineering, and it was hell. But I learned probably the most about what to expect in the future from that class, and I relied on it for years to come later. Second class that was in my curriculum that I liked the best was discrete math. And there's no reason to like that class. It's horrible by all accounts, but the teacher was someone that was, I adored them. So anything they wanted to say to me, I wanted to learn. And it happened to be, he was a discrete math teacher. And I think I got like, kind of an odd story, but all of our homework, even way back then, was all done online. And I found a pretty interesting set of bugs in the software where I could basically get the software to tell me all the answers in advance. So I had perfect hundreds on all my assignments, but then when it would come time to the test, I'd get like D's. And I went to the professor and he was like, this is so weird. I was like, oh no, that's because the thing is broken. It gives me the answer. He's like, well, you shouldn't be penalized for that. And I was like, whoo. He's like, let's get your grades up on the test then. He was a great teacher. But yeah, the software engineering was by far the most practical.
That's kind of funny because that's like the exact sort of thing like cybersecurity specialists do on like a daily basis, is like find bugs like that. Yeah. And that's I kind of find it interesting that you didn't go into cybersecurity actually.
So I wound up taking a couple interesting security classes, and one of our projects was to break everyone's password at the university. So we hijacked all the labs and had them run password crackers, and we saw how many passwords we could get the entire campus. So
dang, okay,
I have an interest
cool.
in that stuff, but there's too much there for me. It's not my thing.
Well, all I can really say is I hope I can do something like that in my later years. But yeah, thanks for the insights. That's really cool. And it also kind of feeds back into the whole the whole concept of like a good leader. Like a bad leader can't make you do anything. So like a good teacher will be able to learn something that you hate. So I think that sort of connection is really interesting there.
Yeah.
But yeah.
No worries. Got some discrete math.
Go ahead, Matt. Sorry, you go. I was going to say, has your love of discrete math or your ability to do discrete math affected your career in any way? Like, what are the benefits of actually having understanding of discrete math relative to like being in industry? Because a lot of students struggle with it, like I do personally as well. And I've sort of like written it off as like, oh, well, I mean, I can make a web app, so why do I need to know how to do this math? But would you say there's like, am I shooting myself in the foot? You know what I mean? Like, is there anything I'm missing out on?
No, discrete math is one of those academic classes. It will not. I was trying to actually just think now, like, was there ever a time I needed to do induction or an inductive proof of a thing or any of the stuff I learned? And the answer is no. I can say that and this wasn't discrete math, I've used big O notation one time in my entire career, and the results were 100% ignored. The exception to that is interviewing. People love to ask big Go stuff during interviews, but practically, doesn't matter.
Are there like maybe in the research field, would you say it's more important, or is it more like to make the distinction between like, I don't know, I become machine learning engineer guy or whatever, and I'm doing like legitimate math or something. Would you say the value goes up in that regard, or is this more of like a general case?
So for typical software industry, quite a lot of things you learn in a standard CS curriculum will not matter. There are going to be exceptions to that. Like your data structures and algorithms classes are going to be the most practical things you learn. Your day-to-day use of them will still be limited, but you will use it. Big O stuff, I mean, those are topics around performance and knowing the boundaries of problems. But the reality is most technology we use is unconstrained in any real meaning. So conversations around Big O just aren't practical anymore until you get into a constrained environment and system. And then, yes, some of the stuff you know about memory management and Big O start to show up. But researchers, sure, they have to use that stuff because papers and math are part of it. The AI and ML group, so I did 3 years of AI research, and I'm trying to think if I ever used that stuff there either. Not aside from working on papers. So it matters for that to prove your algorithms and your formula are all bounded correctly and to know the limitations, but on a practical side to build it still doesn't matter.
Interesting.
Not like you don't like hearing that, do you?
No. I'm genuinely curious. I don't really like it either myself. I was just interested in hearing your opinion, because I don't know. I've sort of knocked it to the side too. It seems like Veronica has a question. So, sorry. Keep going if you have anything. But yeah, I just want to.
Yeah. Do you want to do the raised hand or? Okay, click on the raise hand button. There you go.
Wait, hello?
Hi.
Oh, hi, Ryan. I don't know if you remember me.
I do.
Okay, awesome. Wait, I actually just thought of an amazing question that I just wanted to know out of pure curiosity because I actually missed half of your talk when I went to dinner, but I know you're a cool guy, so I'm gonna ask anyways. I like what I hear about like my brother, he goes to like co-op and whatnot, right? It's like he has like these moments of total humility where you have to be knocked off of your high horse. Have you ever built up so much pride in what you, or like confidence where it's like too much and someone just had to come and crush you, but that helped you?
So before I left school, I realized and had kind of come to terms with I was never going to be the best developer. There were plenty of other people who were better than me. What I knew I would bring to the table was that I could work well with a lot of different people. And so I kind of took a little bit of comfort in that. Now, that doesn't mean there haven't been some like hard knocks in my career that forced me to go and change and learn, but I wouldn't say they're quite as maybe direct as people would assume. So my very first job was at a startup and we went out of business. And so the getting drawn into the dream of you're going to build this product, it's going to be amazing, and then we can't pay you, and then please hang on, and then please come help us move stuff out of the office. That hurt, it made me wonder, what was all that for, and what should I have done differently, and how responsible did I feel for it? I was at a job where I had to file HR complaints because I felt I was being harassed. That happened. So there are some distressing things that can happen in our field, and they do force me to grow and change, but in unpredictable ways, I would say. But the humility thing, that feels like, man, I still have these moments, but I'm definitely, I tell people that if you ever want me to be on your technical team, it's the worst mistake they can make, because I have really strong opinions about how they should work, and I'm not going to back off of them. I can support it. I can be nice and whatever, but firm. And I'm only like that when I'm writing code. And I had to learn to stop doing that because it wasn't very helpful. It wasn't very effective. And earlier in my career, I was wrong plenty of times. I didn't know enough to support my firmness, I guess. So yeah, it's a little bit of a school of hard knocks, but I don't know if it's quite exactly maybe someone shows me something and I'm like, oh crap, I had no idea. I don't remember too many of those moments, but I could just be filtering them out. It's mostly weird stuff happened that was upsetting, and I had to figure out what to do about it.
Cool. Thank you.
You bet. We got about 4 minutes left. Any other questions? And then, I guess anything you want, totally fine.
I have another mini question.
Yeah.
So I've had a debate with a lot of different people about, there's something some people do on their resumes where they include like skill bar. They rate their own skill. What is your opinion on that?
All right, shameless plug. If any of you want me to review your resume, I will send it to me without your information. I'll do a 10-minute video of your anonymous resume, and I'll give you all the answers. But since you asked, don't ever put a rating for your own skills in your resume. Never, ever. And the reason is, when you say, let's say you did it out of stars, 5 stars, right? Say 2 stars, because you're a student. Why would I want to hire a 2-star developer? If you put 4 stars, so you think you're almost an expert, huh? You're going to go against me? Cool. I'm going to ask you about garbage collection. Let's go. You don't want to put yourself in the position for a judgy interviewer to say you're either not skilled enough or you think you're that skilled. It's a trap you can't get out of. So let the interview convince the company of how good you are. Don't don't give them information that they could judge you poorly for, and ratings can kind of only do that. Yeah, Michelle, it's pretty much loose. Because if someone with a decade of specialized experience and you say you're 4 out of 5 stars, they're going to come in and find out if you are, and you won't be at that level. There's no way to say 4 out of 5 stars means one thing to one grade and to another, so it's going to backfire most of the time.
What would you say then? So what would you recommend for someone, like, let's say I'm like sort of good at something, but I'm not like an expert at something. How should I display that on a resume then?
So what I recommend for people to do on the resume is just list the skills that you have, skills and knowledge that you have. And if you can hold a conversation about it, you can put it down. You let the interview process convince people of your strength or weakness around it. Like, why would you go ahead and tell a company you're crap at something? That will not help you. And I'm not saying you should lie about anything, but you're trying to get a job so you can pay your bills and have a lifestyle you want. Don't necessarily give them a reason to tell you no when the interview process is already geared to kick you out. Don't give them any more reasons to do it. So just put your skills and let the interview figure that out. Does that make sense?
Yeah, I think so. I agree with that sentiment.
So, Erica, you said a thing about if they're trying to set up a trap. I wouldn't describe it as a trap, mainly because the people who interview people were never trained to do it. You get thrown into an interview. Once you're a senior engineer, you will interview people, and no one will tell you how to do it. They may not even give you questions to ask. So you will see a resume, and it might be the first resume I've ever read from the perspective of, should I bring this person onto the team or not? And when you see a rating, you're going to have a reaction to it, and you're going to decide you want to ask questions. So it's more of a recognition that the people who are going to be interviewing you just have no idea what they're doing. So their job is to judge you. That doesn't mean they're going to do it fairly or ethically or even legally. So it may not be a trap. It's just crappy circumstances piled up. So you don't want to give them any more reason to make a mistake. And in the US, illegal interviews happen all the time. Right. I typically, my position on software interviews is that they're built to keep bad people away. They're not built to find good people. So the whole process is built around weeding out, like why you need to be able to answer on the phone esoteric tech questions that will never come up in the job. It's only to weed people out. Your in-depth knowledge of how Quicksort works has no material value to the company whatsoever, but it's a really easy way to disqualify people. So you don't want to give them any more reason to judge you unfairly or poorly. That's what it's already trying to do. Okay. Does anything come to mind in terms of what to look for in a first full-time development position and how you might be able to assess whether the role has some of those qualities ahead of time? I'm not sure what qualities you're thinking about, but what I would say is my approach to software interviews is to recognize that people don't know what they're doing, and so you will be interviewed poorly. So everything you want to do is to get as any tiny little favorable things to your side to convince a yes to you. Now, they could be a great company, they're still going to interview you terribly. They could be a terrible company and still interview you terribly. The interview has nothing to do with the company. They're like disconnected parts of the whole thing. So, on the one hand, just go ahead and assume you'll be interviewed by a bunch of people who shouldn't be interviewing you. Prepare for that. Now, the other question about how do you know it's a good company or not, a skill you develop while you interview is interviewing them back in turn. Because you're signing up for at least 6 months of your life when you join that company, and if it's an absolute hellhole, it can really wear you out and leave you with some bad memories and really discourage you. So you want to know what kind of dumpster fire you walk into. So you learn to ask questions like, what keeps you here? If you could get a job anywhere else, why do you stay here? Or if there's one thing you could change today about how things are, what would you change? There are a lot of questions like that you can begin to figure out what's going on behind the scenes in the company that may not have told you. Because people aren't trained to interview, they're also not trained to lie to you. So they'll answer the question. It's kind of funny. But those questions are in my book. But yeah, so a couple of small pointers that I would typically say to avoid, unless you really, really want this, try to avoid startups going out of the gate, unless you really, really do want you want the crazy lifestyle that comes with it, which could mean you don't get paid, right? There's a lot of weird stuff that comes with startups, and if you want that experience, go for it, but just recognize it's not stable. Good question to ask startups is, how much rate do you have? And if they don't want to answer the question, just know that means they probably don't have money. Startups are typically a no-no that I steer first-time developers away from, because it's crazy. If it's your thing, go for it, but it's usually not exactly what most people want to sign up for out of the gate. The other thing I would typically say to stay away from is any job that says full stack, rockstar, ninja, cowboy. If they say those words, get out of that. Those are words that are typically indicative of a horrible work-life balance, that they're trying to extract far more labor out of you than they're willing to compensate. You may desire to be well-rated like a full-stack developer, but you almost never want to work for a company that seeks a full-stack developer, because no developer wants to write code, maintain a database, manage all the infrastructure, take all the support tickets, write all the documentation. No one wants to do all that on one person's salary and 40 hours a week, because it's not 40 hours a week. So you want to stay away from those things. They're typically red flags. Here's my little synopsis there. But otherwise, go for it. All right, it's 5 after. We can do one more question.
I have like a mini question if no one else comes up with a question, but I'll wait to make sure to see if there's anyone else.
Sure. And like I said, everyone, I hope that this is just the first time I get to speak with you all. So if you ever want me to come back to talk about any one particular thing, just say so, and I will. Happy to do it. I loved having outside people come talk to us when I was at university. So if you enjoy the same and want to hear from me again, just say so.
Yeah, definitely. Thank you for coming.
Yeah. Advice for people struggling with their CS courses. That's kind of a tough one for me, because I definitely did struggle. The things I wish I had done differently in college for myself, and I don't know if it's true for you, but I wish I had spent more time in my professors' offices. And I wish I had stayed on top of things a little more. I tend to let assignments pile up, and then I didn't have time, and right on the heels of an assignment was a test, and just felt like I'd never catch up. So nothing really seemed to stick very well. And all that is solvable. It's just not fun, right? It's a chore to do that thing. One technique that I do typically teach people, though, is a Pomodoro technique, which was ironically built out of being in school. But it kind of teaches you to maximize your focus. Because focus is one of the bigger problems, right? You could stare at material all day long, but you just can't, you're not focused, so nothing sinks in. Pomodoro technique is specifically built to build up your focus. So 25 minutes of 100% focused work is worth hours of unfocused work. And that makes a massive difference. So my kind of off the cuff recommendation is, I mean, I'm going to be a bit of a turd about it and say not all your classes are going to, depending on what you want to do with your degree, not all your classes are going to be the biggest deal in the world, and no one cares about your grades when you're done, and no one cares about your GPA. Very few people do, I should say. So get the grades you need to get, and don't beat yourself up if it's not perfect, right? Like, very few companies will ask anything about what you studied or where you went to school. None of that stuff's about to matter. So learn because it's going to be good. Like, it's enjoyable for what it is, but then develop a system that works for you to beat the class, get the grade you need. Like, I'm very cool in that regard, and I know what I should have done in school, but it was go to the teachers, make myself as annoying as I can to them. They wanted to help me. I just didn't want to go ask, and then figure out how I should deal with my day. So I'm not focused all day long, but really dedicated, focused times where I do get something out of it. I wish I had done that. So now, I have multiple clients. I wrote a book. I speak at conferences all over the country, and I juggle that crap. And I have kids. Like, that problem never goes away. You just learn to deal with it. I wish I figured it out in school. But what class is math? Probably the most significant ones for me were a software engineering class, which was a really good exposure on methods, techniques, processes, all that kind of stuff, because that stuff was real. And data structures and analysis. Data structures and algorithms were probably the next most useful in terms of a standard software career, because you do use data structures and algorithms all the time, not to the depth you have to learn them in school, but you do have to recognize that this is an application for a dictionary or a set, or I should sort these first for this reason, or that stuff's all day long. All day long are those problems. And actually the video I have in my thing is me solving a common data structure problem about the maximum or minimum item out of a set, which is a problem you will solve 1,000 times. Cool. So if you go to my website, you can email me, you can contact me on LinkedIn. You never have to stop. You can always call me. You can always reach out to me. I'm here to help you guys from now on. That's the thing. So don't hesitate to reach out with anything you got, but I think it's time to call it a night and let you guys get to your hard work. I will get a video out to Matthew and anything else you guys need. But yeah, let me know how else I can keep helping. Any other topics you want me to talk through or do a workshop hands-on with y'all? Just say so. Thanks.
Yeah, thank you. Oh.
Making a game, entity component system, baby. Yeah, go do it.
Just wanted to say thank you for coming out, and we'll definitely have all the resources posted on the CCSS website for those of you who are students here and are looking to get the recording later on, or we'll post the link to his website and all the other resources that were included in this presentation there as soon as we get them.
Yep. And thanks again, everyone. And I'm sincere. You can contact me. I'm a real person. That's legit. All right. Have a good night, everyone.